Hi, this is Sankarappa. Today we will discuss about voltage regulator. We know the application of the GNR diode. GNR diode, one of the application is voltage regulator. GNR diode can be used as the voltage regulator. Now, it is a circuit diagram used for the regulator. Here, a GNR diode and one resistor and variable load resistance, a fixed voltage source, and to measure the value of voltage. These are the components are required, and it is the table required to find out the regulation, percentage of regulation, by using the formula of VNL minus VFL by VFL into 100. No load voltage, VNL is the no load voltage, VFL is the full load voltage. Now we can see how this will be connected on the circuit diagram, based on the circuit diagram, and how it can works. Now we can see it is the breadboard, and this will be the GNR diode. This is the GNR diode, this is the GNR diode, and this marking symbol, black symbol, will be the cathode, and this one is the anode. Anode is to be grounded and cathode is to be connected to one terminal of the resistor. It is one terminal of the resistor, and second terminal of the resistor will be connected to the voltage, voltmeter, supply voltage. So it is to be connected to the supply voltage positive, and negative of the supply voltage is connected to the ground. It is connected to the ground, and then this load resistance, variable load resistance, is to be connected across the GNR diode. Initially, no load voltage to be calculated. So initially, let we consider a no load voltage. A corresponding no load voltage to be measured at 6.65 for 15 volts. Let it be 15. So it is around 15. So it is 15. For 15, it has the value of 6.67 volts. Now we can apply slowly the load resistance. So initially it may be kept at 100 volts. So let me change this to 100. By putting it to 100 volts, by marking it to 100 volts, by giving the 100 ohms, we can measure the variation of the voltage, 1.67. It is a VFL for 100. Next, we can give the 500 ohms. 500 ohms of resistance to be given. Correspondingly, the variation of the voltage is 5.23. Next, we can increase to 1K. So let it be, this is 1K. So it is 1K. For 1K, the value of that one is 6.59. Then we can give it to 2K, 3K, 5K. For let it be 5K. For 5K, it's around 6.63. Then we can increase to 10K. It is 10K. This one is 10K. For 10K, it has the value of 6.65. Later we can increase to 20K, 30K, and etc. is to be increased. It is 20K, 30K, 40K. So for example, 50K. For 50K, it's around 6.67. So that means we can observe that only up to the certain level it is to be increased linearly. After that, it is to be constant. So here we can observe for 70K, it's around 6.67. So let it be, it is 50K. For 50K also same. For 20K, it's around 6.67. Let it be, it's around 500 ohms. For 500 ohms, it's around 6.67. If it is to be some 200 ohms also same. So initially it has the value. So based on this value, we can draw the graphical representation. So by taking load voltage on x-axis, output voltage on y-axis, by noting the voltage and regulation, percentage of regulation calculation, we can draw the corresponding curve, model curve, or the graphical representation of this voltage regulator, GNR diode voltage regulator. So it's about GNR diode as a voltage regulator. Thank you.